I greet you. Welcome to today's class. As usual, we have our classes on Wednesday from 1 to 2 p.m. So today, as usual, is another Wednesday. We are here again for us to learn and for us to have something during this period where students are at home. So I want to welcome all students, all interested viewers, all the well-wishers. You are welcome to watch. It is free. You only need to buy bundles and have a smartphone. And then you tune in. My Facebook is Shadrach Kiprotich Kirwa. So welcome everyone and feel at home. So we have had for the last 1 month, we have done quite a number of lessons on Wednesday for the last 5 Wednesdays every week. So I want to also urge all of us to keep on sharing. I want to thank those who have shared my videos, those who have watched. I want to thank you and urge you to keep on sharing for more students to watch this at the comfort of their homes. So today we are going to look at structure and bonding. This is a Form 2 topic. Structure and bonding, or bonding and structure, is a Form 2 topic, and I hope we all are going to enjoy and partake in this. Always, if you have any questions, you can post it at the comment box, and I will answer you accordingly. So thank you and welcome. So we are going to look at structure and bonding. Okay. So to start us off, let us just review something that we did in introduction, the first topic, that is atomic structure and the periodic table. So there is something that we did. We said atoms. We talked about atoms. The elements that are found on the periodic table, the first 20 elements of the periodic table, and we said atoms are stable, are said to be stable if they have 2 or 8 electrons in their valence energy levels. So atoms are said to be stable only if they have 2 or 8 electrons in their valence shells. Now 2 electrons is said to be, so that is stable duplet, or stable octet. Those atoms which have 2 electrons or 8 electrons in the outermost energy level are said to be stable. Now these ones, they are stability of 2 is referred to as a stable duplet, while those ones that have 8 electrons in the outermost energy level are said to have an octet. So we have an octet and a duplet. This is a characteristic of group 8 elements. If you look at group 8 elements, for example, helium, the first member is helium, and then followed by neon, followed by argon, and the rest which are not in the first 20 elements. So neon has electron configuration of 2. Neon is 2. Helium is 2. Neon is 2, 8. Argon is 2, 8, 8. So we are saying atoms are said to be stable if they have 2 or 8 electrons in their valence energy levels. Valence energy levels, in other words, is the outermost energy level. So the outermost energy level for helium has 2 electrons. The outermost energy level for neon has 8 electrons. The outermost energy level for argon has 8 electrons. So this is referred to as a stable duplet. This one is referred to as octet. So these two are said to have an octet. So stability of 2 is called duplet. Stability of 8 is called octet. So these are group 8 elements. Something else also we need to note, number 2, point to note number 2 is, so group 8 elements are stable. So all group 8 elements are stable. When we say group 8 elements, we mean the noble gases. So noble gases are stable because they either have an octet or a duplet. And the examples we have seen. Otherwise, all the other atoms either lose, gain, or delocalize their electrons to be stable. So all the other atoms except noble gases, except group 8, all the others either lose or gain or delocalize their electrons in order to be stable. So this is what now makes elements. When we in a previous topic before this, you talk about ion formation. Ion formation includes the losing and gaining of electrons for an element to be stable. When we looked at that, we say that all metals lose electrons, non-metals gain electrons, and I forgot one thing here. They either lose, gain, delocalize. There is something else also, share. So all the other atoms either lose, gain, share, or delocalize. So those are 4. They either lose, gain, share, or delocalize in order to be stable. So that happens during ion formation. So now it brings us to structure. This brings us now to bonding. So we say when two or more atoms combine, they form a chemical bond. When two or more atoms combine, they form a chemical bond. That is, they combine by losing, gaining, sharing, or delocalizing their electrons. So when they combine in such a manner, then they form what is called a chemical bond. So that is, those are things that we need to know. Now, when they form a chemical bond, we have 3 types of. There are 3 types of chemical bonds. We shall look at each one of them. 1 is ionic bond. 2 is covalent bond. And 3 is metallic. So there are 3 types of bonds, 3 types of chemical bonds, depending on whether atoms lose or gain or share or delocalize the electrons. So there are 3. We have ionic bond, covalent bond, and metallic bond. So let us begin with ionic bond. Let's look at one. So one ionic bond. Okay, so ionic bond is defined as the electrostatic force of attraction between a stable positively charged atom. In this case, a stable positively charged atom is said to be a cation, and a stable negatively charged atom. A stable negatively charged atom is called an anion. So that is ionic bond, defined as the electrostatic force of attraction between a stable positively charged atom, that is the cation, and a stable negatively charged atom, the anion. Also, something to note about ionic bond is that it involves complete transfer of electrons from one atom to the other. Ionic bond involves complete transfer of electrons from one atom to the other during bonding. So that is a ionic bond. So we need to note here that when we say positively charged atom, that is a cation. So it says the same as saying an electrostatic force of attraction between a cation and an anion. That one is called ionic bond. Sometimes it is also referred to as electrovalent. It is also referred to as an electrovalent force of attraction. It is also referred to as an electrovalent force of attraction. So that is what we need to note about the ionic bond, that it exists between a cation and an anion. It also involves complete, mark the word complete transfer of electrons from one atom to the other. So that is what we say. It involves one atom has to lose the electrons and the other atom gains the electrons. So that is a ionic bond in brief. Now when we are doing structure and bonding, we are only interested with the outermost number of electrons. That is what we call valence electrons. That's why an ionic bond is also referred to as electrovalent. So let us look at examples of ionic bond illustrations. Illustration of ionic bond. One, we look at the bond between sodium and chlorine to form sodium chloride. Now, so consider sodium chloride. Sodium is atomic number 11 chlorine is atomic number 17. Now, if you consider these two, the electron configuration of sodium is 281. Electron configuration of chlorine is 287. The electron configuration of sodium is 281 to make it 11. Chlorine is 287 to make it 17. Now, one thing here we need to know about this is that sodium loses one electron to be stable, while chlorine gains one electron to be stable. So in order for sodium to be stable, it loses one electron. When it loses one electron, it attains the stability of the noble gases, that is 2,8. When chlorine gains one electron, it attains the stable electron configuration, which is 288. So that one, sodium now, so when we are doing illustration, we will only use the outermost energy level. We'll only use electrons in the outermost energy. We are only using electrons in the outermost energy level, which are either lost or gained. So for example, for sodium, so when sodium combines with chlorine, so sodium is 281. So we are using dots and crosses. We are using dots and crosses to represent the electrons. So that when I write a dot here, a cross here, for example, then it represents the one electron for sodium. Combines with chlorine. Combines with chlorine. So when I use dots cross for sodium, I use dots for chlorine. So chlorine will be, because this is 281, this is 287. So chlorine will be those are 7 electrons. So 1, 2, 3, 4, 5, 6, 7 for chlorine. Now when these two combine, then we are saying sodium will lose this one electron. So this one electron for sodium will be transferred here. So that now sodium was 281. When it loses one electron, then it becomes 28. So you have, let me draw it down here. So sodium will be, you will remain with 8. So when sodium loses one electron, then you remain with 8 electrons in the outermost energy level. So this and chlorine. So now when it has lost one electron, so you enclose with a square bracket like that and then positive to show that it loses one. So when it loses one, then you enclose with a square bracket to show that it is an ion. So this is sodium ion, which is 2,8. What has happened? It has lost one electron. So this is sodium ion. Then chlorine now it was 287. So this one is transferred. That is why we say it involves complete transfer. So this one will be transferred here. So you have chlorine, and then the one that came in is an X. So you enclose also with a square bracket like that, and then negative. So this is chloride ion. So this one is chloride ion, which is 288. So that is a bond between sodium and chlorine. Let us revisit this again. Sodium atom. This is sodium atom. This is chlorine atom. So sodium atom is 281. In order for sodium to be stable, we said for sodium to be stable, it loses one. So we need to know that all metals lose electrons. So metals lose electrons while non-metals gain. So sodium is a metal. It loses an electron. So it loses one electron in order to be stable. So that it has now 2A. Chlorine has 7 electrons in the outermost energy level. So that means it does not lose. So it gains 1 electron in order to be stable. So sodium loses 1 and then chlorine gains the same. So that's why we have this is 288 and this one is 28. So now you remember we talked about a stable duplet and a stable octet. So if you look at this is 28, that is a stable octet. This 288, a stable octet, because duplet is 2 and octet is 8. So that is for sodium chloride. I hope that one is clear. So this is sodium atom, chlorine atom. This is sodium ion. This is chloride ion also. So you remember in our initial discussion here, we said a stable positively charged atom, which is called an ion. A cation. So in this sense, sodium now becomes the cation. And then the negatively charged ion is referred to as an ion. So chlorine or chloride ion becomes the anion. So that is what happens during that kind of bonding. Number 2, so that was illustration number 1. Illustration number 2. Illustration number 2, let us look at magnesium oxide. We know that magnesium is atomic number 12 and oxygen is atomic number 6. Not 6, 8. Oxygen is 8, magnesium is 12. So electron configuration of magnesium is 282. Oxygen is 26. Basically, as we've said, magnesium loses 2, oxygen gains 2. So when you show that illustration, magnesium atom. So we draw 2, and then oxygen we show 6. So because this one we have used cross, then we are using dots for oxygen. So oxygen will be 6. 1, 2, 3, 4, 5, 6. So this is magnesium atom, oxygen atom. So magnesium atom we have said is 2, 8, 2. Oxygen atom is 2, 6. Now, ionic bond involves complete transfer of electrons. Because oxygen requires two electrons to be stable, so these two are lost by magnesium and they attach there. It's not a must you show this. I'm just showing you for the purpose of understanding. So when magnesium loses 2, when it loses 2, you will remain with 8 in the outermost energy level. So you have magnesium remains with 8. So 1, 2, 3, 4, 5, 6, 7, 8. Again, you remember we said you enclose with a square bracket. And because they are 2, then it becomes 2 positive. So that's magnesium ion. Now oxygen will be the electrons that were there already. Then you have 2 crosses that came from magnesium. Again, you enclose with a square bracket and you write there 2 negative. So this is magnesium ion. The ion is 2, 8. This oxygen ion, the ion is 2, 8 also. So magnesium loses 2, become 2, 8. Oxygen gains 2, becomes 2, 8. So this is magnesium ion. This is oxygen oxide. So that is for magnesium and oxygen. So again, magnesium loses 2, oxygen gains 2. So I hope that is it again. You remember also we said here that this bond, ionic bond, involves complete transfer of electrons from one atom to the other. So therefore here there is complete transfer of electrons from magnesium to oxygen atom. So this one becomes the cation. Magnesium now becomes the cation because it is positively charged. Oxygen becomes the anion because it is negatively charged. So that is 2, 3. 3. Let us look at a bond between sodium and oxygen to form sodium oxide. When you were in the previous topic again, just to make a recap, in a previous topic, we learned about how to write chemical formula so that you have sodium loses 1. We said sodium loses 1. So the valency of sodium is 1. The valency of oxygen is 2. So when you exchange the valencies, you have Na2O. That's why we are writing the formula of sodium oxide like this. Now this formula, when you write sodium oxide like that, we know that sodium is 11, atomic number 11. Oxygen is atomic number 8. Now the electron configuration of sodium is 281, as we've already said. The electron configuration of oxygen is 2,6, as we have already said. Looking at these two closely, we said sodium loses 1. Oxygen gains 2. Again, sodium loses 1. Oxygen gains 2. That means if sodium is losing 1, oxygen is gaining 2. So let us imagine, say, that oxygen gains 2, sodium loses 1. That simply means for every 1 oxygen, you require 2 sodiums. Okay? For every 1 oxygen, you require 2 sodiums. Because 1 sodium loses 1 and 1 oxygen gains 2. Okay. Okay, so at this point now, we are saying that when you write a formula like this, when you write Na2O, it simply means you require 2 sodiums and 1 oxygen. So in short, we need 2 sodium and 1 oxygen atom in order to form ionic bond. So let's do the illustration here. So that is sodium oxide. We have said sodium is 281, oxygen is 8, and then oxygen is 26. So you have sodium atom here, 1, and then you have oxygen, 6. No. Let me use dots for oxygen. So 1, 2, 3, 4, 5, 6. So that is oxygen atom 2, 8, 2, 6. This sodium atom 2, 8, 1. We have said you require 2 sodiums. So because you require 2 sodiums for 1 oxygen, then you put 2, coefficient 2 in front of sodium. That gives you, so sodium loses 1, so it becomes, so when it loses 1, you remain with 8. So that is 1, 2, 3, 4, 5, 6, 7, 8. Again, we said enclose with a square bracket. Because it is sodium, there is a positive there. And this one is sodium ion, which is 2, 8. Plus oxygen. Oxygen gains 2, so you have 1, 2, 3, 4, 5, 6, and then you have for every, so we had 2 sodium. So 1 sodium gives 1 X, the other sodium gives another X, and then you enclose with a square bracket. That is 2 negative. So this is oxide, oxygen ion, which is 2, 8. So simply that is how you illustrate. Instead of writing 2, some people prefer to draw 2 sodium. That is still okay. So instead of writing 2 here, you draw 1 sodium and another one here, for example, sodium. So instead of that, some people prefer to draw, which is still okay. So we are saying that you require 2 sodium, so that when 1 electron comes here, the other electron comes there. So instead of doing this, because it takes a lot of time, instead of drawing 2, then you just simply write here 2 to show that for every 1 oxygen you require 2 sodiums. That's why for every 1 oxygen, yes, you require 1 sodium. That is why you write it as Na2O, to show for every 1 oxygen you need 2 sodium atoms. So that is it. Maybe we can take one last example. Those are 3 already. Let us look at one last example. Maybe we do aluminium oxide. Now, aluminium oxide is written as Al2O3. That is, aluminium has a valency of 3. Oxygen has a valency of 2. So when you exchange the valencies, it becomes Al2O3. So that's the formula of aluminium oxide. Now, aluminium, we know, is number 13. atomic number 13. Oxygen is atomic number 8. So electron configuration of aluminium is 2, 8, 3. And electron configuration of oxygen, as we have said, is 2, 6. So when you write Al2, it simply means you require 2 aluminiums for every 3 oxygens. So as we looked at for sodium, we said for sodium, when you have Na2, it means you require 2 sodium. So similarly here, we require 2 aluminiums and 3 oxygens. So you draw aluminium. You remember we are only drawing the outermost energy levels. So aluminium is 3. The outermost energy level has 3 electrons. For oxygen, as we have said, the outermost energy level has 6. So that is 1, 2, 3, 4, 5, 6. So the outermost energy level are 6. Because we have said 2, so we have Al2, you require 2 aluminiums. O3, you require 3 oxygens. So that gives you, so aluminium will lose 3. Aluminium loses 3. That means it will have, so this 2, 8, 3, this 2, 6. So you have aluminium atom, aluminium ion. When it loses 3, the outermost energy level will have 8 electrons. So you have 1, 2, 3, 4, 5, 6, 7, 8. So that is aluminium atom. So you enclose with a square bracket and then 3 positive to show that it has lost 3. On the other side, so this is aluminium ion, 2, 8. Oxygen, on the other hand, will have 6, and then it gains 2. So you have 2 crosses there, again enclosed with a square bracket, and 2 negative. So this is oxide ion 2, 8. Also we said 2, so you remember the 2 here, and oxygen is 3, you remember the 3 there. So that is aluminium oxide. So simply that is ionic bond. We have said it involves complete transfer of electrons from one atom to the other atom. So a positively charged atom, as we have said, is a cation. A negatively charged ion is called an anion. So in this case also here, aluminium ion, because it is positively charged, becomes the cation. Oxygen, because it is negatively charged, becomes the anion. So that is what we have for this. So you can try 5. You can try lithium chloride. Lithium is number 3 and chlorine is number 17. So you can try ionic bond between lithium and chlorine. You can also try calcium oxide. Calcium is number 20. Oxygen is atomic number 8. So you can try that. Try it out. If you like, you can draw and then take a picture and put it in my comment box. I will upload it in my comment box. I'll check on that. So do lithium chloride, calcium oxide. So your assignment is here. Lithium chloride, lithium is 3, atomic number 3. Chlorine is atomic number 17. Calcium oxide, calcium is atomic number 20. Oxygen is atomic number 8. So that is atomic bond. Very good. So let us make a few notes about ionic bond. So we've said ionic bond is between a metal. Ionic bond is a bond between a metal and a non-metal, where a metal loses electron, where a metal loses the electrons and the non-metal gain. Ionic bond is a bond between a metal and a non-metal, where a metal loses electrons, either electrons or electron. It can be one or many, and the electrons lost by the metal are gained by the non-metal. Again, we also need to mention examples of ionic bonded compounds. Examples of ionic compounds, including what we have said already. We have sodium oxide. Let me write the formulas. So we have sodium oxide, potassium oxide, potassium chloride, magnesium chloride, etc. So many of them. We even have sodium sulfate. Sodium sulfate, we have ammonium sulfate. Ammonium sulfate is 2, and then sulfate, and so on. There are very many. Potassium sulfate, potassium carbonate, those salts are said to be ionic compounds. So that is the bond. Now these ionic bonded compounds, ionic bonded compounds have giant ionic structure. Ionic bonded compounds have giant ionic structure. Maybe we need to say a structure is a pattern formed by the bonding atoms. When atoms bond, they form a certain pattern, a certain repeated pattern. That pattern is referred to as a structure. So all ionic bonded compounds, they form a structure called giant ionic structure. And thus the topic yes. So the topic, our topic was structure and bonding. So once you've learned about a bond, every bond contains its own structure. So when we say ionic bond, then it has its own structure. Covalent bond has its own structure. Metallic bond has its own structure. So for this case, for ionic bond, that's why we've said here, all ionic bonded compounds contain giant ionic structure. Now, characteristics of giant ionic structure or characteristics of ionic compounds. Characteristics of ionic compounds. When we say ionic compounds, in short, we mean compounds with giant ionic structure. So examples are characteristics of ionic compounds, working sodium oxide, sodium chloride, and so on. One is that they have high melting and boiling points, because they are very strong. Giant ionic structure consists of atoms which have very strong bonds. So because ionic bond is a very strong bond, then it has high melting and boiling points. So the boiling and melting points of ionic compounds are very high because the bond is very strong. Number two is that they conduct electricity. They conduct electricity only in molten or aqueous state. But does not conduct electricity in solid state or solid form. They only conduct electricity in molten or aqueous state, but does not conduct electricity in solid form. The reason for this is because in aqueous or molten form, there are mobile ions. But in solid form, the ions are not mobile. For example, we've talked about sodium chloride. So sodium chloride is crystalline in nature. It is crystalline. So because it is crystalline, in solid form, there are no mobile ions. So, but when it is dissolved, when we talk about aqueous state or aqueous state is when it is dissolved in water. Aqueous state is when it is dissolved in water. Molten form is when it is heated. When it is heated. When it is heated, it melts. That is what we call molten form. When it is dissolved in water, it forms a solution. That is what we call aqueous state. So in aqueous state, we will have sodium ions. So when this one is dissolved in water, then you have, or when either dissolved in water or heated, then you have sodium ions and chloride ions. These ions will move about the water or the melt. When it moves about the melt or moves about the water, then they are said to be mobile. That's why we are saying mobile ions. Now, these mobile ions is what is enabling it to conduct electricity. That's why we've said it conducts electricity only in molten form or aqueous form, but does not conduct electricity in solid form. So that is 2. Number three is that they are soluble in water. These ionic compounds are soluble in water. Sodium oxide, sodium chloride, potassium oxide, potassium chloride, ammonium phosphate, aluminium oxide, all of them they are able to dissolve in water. Basically, that's what we said in Form 1, that they dissolve in water to form bases. For example, sodium oxide, you dissolve in water, it forms sodium hydroxide, potassium hydroxide, which are bases. So that is these are the characteristics of ionic bonded compounds. So let us do a quick recap of what we have talked about today. So we have done introduction to structure and bonding, and just as a reminder, we have said a chemical bond is formed when atoms either gain or lose electrons, or share electrons, or they delocalize their electrons. And a chemical bond is either formed when an atom or atoms gain, lose, share, or delocalize their electrons. When they gain and lose, as we have said for ionic compounds, where sodium loses, chlorine gains. So when they lose or gain, that is, one atom loses, the other one gains. You see, we have said this is ionic. So when atoms lose or gain, it forms ionic bond. When atoms share electrons, then this one forms covalent bond. Okay? When atoms share electrons, none of them loses, none of them gains. We shall look at it. We call it covalent bond. When atoms delocalize their electrons, instead of losing, instead of gaining, instead of sharing, they delocalize. We shall also look at it. This one forms metallic. So you realize these are the three types of bonds that we said we have. We have ionic bond, we have covalent, and then we have metallic. And in our next discussion, we shall look at covalent bond and the sharing of electrons. So here, today, we have talked about ionic bond. We have said ionic bond involves complete transfer of electrons, where one atom loses the electrons and the other atom gains the electrons. We have also looked at the giant atomic structure, for example, in sodium chloride. Now, when you look at sodium chloride, the structure for sodium chloride, I've said a structure is a repeated pattern. For example, in sodium chloride, every sodium in sodium chloride, every sodium is surrounded by 6 chlorines. Every sodium is surrounded by 6 chlorines. And also, every chlorine or chloride is surrounded by 6 sodiums. So every sodium is surrounded by 6 chlorine. Every chlorine is surrounded by 6 sodiums, vice versa. So in so doing, they form what we said is called a giant ionic structure. That's why we define the structure as a pattern. So this is a repeated pattern to form sodium chloride crystal. So these are the characteristics of the ionic compounds. They have high melting and boiling points. They are good conductors of electricity, but only in molten. You mark the word only. Only in molten or aqueous state, but does not conduct electricity in solid form. The reason for that, we have said, is because in aqueous state or molten form, you can call it state or form. In either one of them, there are mobile ions which are able to conduct electricity. But in solid state, the ions are localized. They are not mobile and therefore does not conduct electricity. So that is our lesson for today. In our next lesson, we shall discuss covalent bond, an instance where atoms share electrons in order to be stable. So in our next lesson, which is Wednesday next week, that is the same day, same time, same venue, we shall talk about covalent bond. So thank you for watching. Thank you for tuning in. I wish you a good week until we meet again. Please share this video to reach more students. Like, comment, give feedback, and God bless you. Bye bye.